This is my advanced 3D hand that I built for under $50. And today we're going to see how well it works by trying to pick things up like a ball, a shoe, a stuffed animal, a cup, and a banana. Getting here took a couple of tries. Until now across my channel, I've had 3 different versions. My first one, I made from cardboard. It actually went viral on TikTok. Since it was a bit too flimsy, I decided to take the same model and 3D print it. I gave it some slightly longer fingers. That brought me to my second version. It copied the same angle of the thumb and was intended to grab things from far away using my extension mechanism. Only that didn't work because it couldn't oppose its thumb and the wrist was fixed in place. That led me to my third and final version. This beauty's got it all. 5 fingers, a wrist, an opposable thumb. It should be able to do all the things a normal hand can do, right? Well, today we're going to find out. But first, let me tell you why I made this. I'm building a full human robot that I can control remotely using my body, kind of like VR. The reason is simple. We have human bodies which are super fragile, and I want to do cool and dangerous things without any consequences. Solutions? I could just not do that, or I can make a full-size robot version of myself that I can control remotely and experience all of those things without any repercussions. Imagine going to space and exploring the surface of the moon or treading around the jungle, all from the safety of your own room. Pretty cool, eh? The mechanisms behind these two are really simple. The glove uses these things called encoders, which can count rotations. I make use of this by attaching a pulley that connects to my fingertip and rotates as I bend it. For the thumb and wrist, I went with these simple gears to measure my movements. All of those rotations are sent to my Arduino, which is like the brain of the robot, which then tells the servo motors how far to spin. The fingers also use pulleys, which are designed to bend with the same range of motion as my fingers. Since servos only turn 180 degrees, I use a circumference calculation to find out how big the roller would need to be in order to fully bend my fingers. And voila! That's all there is to it. Alright, let's add that all up. The encoders were $6.90, the Arduino came up to $10.56, the servos were $9.99, plastic came up to $8.12, AC adapter $11.52, and the 10 kilogram servo was $2.88. Keep in mind, I went with the 20 kilogram servo, but they both fit and it was initially designed for the 10 kilogram. All of that comes up to just shy of $50. Now that that's all out of the way, let's build it. Okay, let's power it up and see if it's working correctly. Now for the part that we've all been waiting for. Let's pick up some stuff. Okay guys, now for a true test of strength. I'm going to let the hand hang on its own weight, no assistance. It made me really happy when it worked correctly. There's just something about making stuff and having it work that really makes all of the long hours all worth it. If I had to do it all over again from scratch, I'd probably use stepper motors instead of servos just because they're allowed to spin a full 360 degrees as opposed to just a 180 degree turn from the servos. And maybe I would use some higher quality encoders so that I can better capture my movements. If you guys like this sort of stuff and you want to see the hands connected to the rest of the body, you should subscribe. Thank you guys so much for watching my first video. To many more.